So they're given alpha beta, the roots of this equation x square plus px plus 3p by 4 equal to 0, and mod alpha minus beta equal to root 10, then p belongs to. Using the relation between the roots, we get straight away alpha plus beta is this and alpha beta is this. And they're also given mod alpha minus beta. To make use of that information, let us consider alpha plus beta whole square plus alpha minus beta the whole square, not the plus, minus between them, equal to 4 alpha beta. Just substitute the values of alpha plus beta, alpha minus beta, and alpha beta. You got a quadratic equation in P. You need not to solve this again. You just can check the sum of the roots from the options. The sum of the root should be 3, and that's happening only here. Yeah, that's the answer. They're given f of z is equal to this, and z is also equal to this. They're asking us to find mod f of z. You just replace this in place of z and then calculate f of z and then its modulus. But the answer is given in terms of mod z. So we know that what is mod z is. Mod z is under root of 1 square plus 2 square, which is root 5. So once you get the answer, you write that in terms of mod z and match with the answer. Just take the f of z and replace the value of z as 1 plus 2i. Just open the bracket in the numerator and then a plus b whole square formula in the denominator. Just take the 2 common in the numerator and then 4 common in the denominator. And these 2 cancel in this 2 times. And then mod f of z equal to the modulus of numerator is a root of 3 square plus 1 by 2 into modulus of denominator root of 1 square plus 1, which is equal to root 10 by 2 root 2. So root 2 cancel and root 5 by 2. We already know that root 5 is mod z. So this is mod z by 2, and that is option 1. They are given z1 is equal to this and then z2 equal to this. They're asking us to find z1 by z2 whole power 50 lysine. Wherever the complex numbers with the higher powers are there, definitely the polar form should be involved in it. So if the polar form, you convert and then you can use the de Moivre's theorem. First you write the z1 by z2, which is equal to root 3 common and 1 plus I. By the denominator, directly root 3 plus I. Usually when you're converting 1 plus I into the polar form, we write mod z equal to root 2 and then cos theta equal to y by r. So 1 by root 2, sine theta equal to 1 by root 2, and from this you get theta equal to pi by 4. And then r equal to this, and r cis theta is root 2 into cos pi by 4 plus I sine pi by 4. So instead of doing all these, when we are the numbers are like well-known trigonometric function values, what we do is we directly multiply with the magnitude and divide with the magnitude. Here also I did the same thing, numerator, and denominator also I did the same thing. I multiplied with the root 2 and divided with root 2 in the numerator. I multiplied with 2 and divided with 2 in the denominator. Now this becomes this root 2 cancel into root 2 times, so root of 3 by 2, and this one becomes cis. Cos plus I sine short form is cis. Cos theta plus I sine theta. The short form is cis theta. So I can write this as a cis pi by 4. And I can write this as cis. The cos value root 3 by 2 and sine value 1 by 2 means it is pi by 6. And we have a formula that the cis theta 1 by cis theta 2 equal to cis of theta 1 minus theta 2. This is straightforward from the Euler form. In Euler form, you can write cis theta 1 as e power I theta 1, and this is e power I theta 2. This is called Euler's form of complex numbers. Then this becomes e power I theta 1 minus I theta 2 is I of theta 1 minus theta 2. So then you get this straight away. just by using that formula, root 3 by 2 into cis pi by 4 minus pi by 6. Pi by 4 minus pi by 6 is pi by 12. Now the z1 by z2, the whole power 50 is what they're asking, which is equal to root 3 by 2 into cis pi by 12, the whole power 50. Now one more property called the De Moivre's theorem, cis theta, the whole power n equal to cis n theta. This is called a De Moivre's theorem. Just apply this De Moivre's theorem, you get this, and this is nothing but 3 by 2 the whole power 25. For the coordinate in which this point lies, to understand that this number doesn't matter for us actually, and this is this 48 pi by 12 plus the 2 pi by 12. So 48 pi by 12 is 4 pi. So the 3 by 2 the whole power 25. And if you understand what is this cis properly, this is cos 4 pi plus 2 pi by 12, which is pi by 6, plus I sine 4 pi plus pi by 6. So you know that 4 pi can be replaced with 0 when it is with a trigonometric function. So cos pi by 4 is positive value and sine pi by 4 is a positive value. And a plus ib is a complex number where a and b are positive. Then that complex number belongs to the first quadrant. The answer is first quadrant. They are given that alpha, beta are the roots of x square minus 2x minus 1 equal to 0. And they're asking us to find the value of this expression. Straight away from the given equation, you can write alpha plus beta is 2 and alpha beta is minus 1. If you write beta power minus 2 as 1 by beta square and alpha power minus 2 as 1 by alpha square. So this is what they're asking. And you do the cross multiplication, you get alpha power 4 plus beta power 4 by alpha beta the whole square, alpha square beta square. So the denominator is straightforward, the minus 1 the whole square. The numerator, the unknown alpha power 4 plus beta power 4, you need to write in terms of known expressions. You can write alpha square plus beta square whole square minus the 2 alpha square beta square. So by alpha square beta square. So you already could simplify this up to one extent. Then this alpha square plus beta square is again alpha plus beta the whole square minus 2 alpha beta the whole square by alpha beta the whole square minus 2 alpha square beta square by alpha square beta square is 2. So what is alpha plus beta? Alpha plus beta is 2. 2 square minus 2 times of minus 1 is plus 2. The whole square by the alpha beta whole square is 1 minus 1 the whole square is 1 minus 2 equal to 4 plus 2 is 6 whole square 36 minus 2 equal to 34. Fourth option is the answer. Just the calculation. The given ABC are real numbers. So when you expand this quadratic equation, all the coefficients will be real numbers. The nature of the roots they're asking. So let us expand this and then write x square minus of a plus b x plus ab plus x square minus of b plus c x plus bc plus x square minus of a plus c x plus ac. You got this by simplification to calculate the discriminant, which is b square minus 4ac, the 2 times of a plus b plus c the whole square minus 4ac, 4 times of a is 3 and then c is ab plus bc plus ca. And if you take the 4 common and a plus b plus c whole square minus 3 times of ab plus bc plus ca, that a plus b plus c the whole square minus 3 times of ab plus bc plus ca. Actually, in the expansion, you'll get to 2ab plus 2bc plus 2ca. So you get this as a square plus b square plus c square minus ab minus bc minus ca. we have a direct result, this expression equal to 1 by 2 into a minus b the whole square plus b minus c the whole square plus c minus a the whole square. If you know that, you can write directly, otherwise no problem. You can derive it in two steps. Multiply that 2 inside, the 2a square plus 2b square plus 2c square minus 2ab minus 2bc minus 2ca, and you take 1a square, 1b square, 2ab. So a minus b the whole square plus b minus c the whole square plus c minus a the whole square. 1b square, 1c square, 2bc you take, and then you know that the sum of the squares can never be negative, so this is greater than or equal to 0. When this cannot be negative, so the roots cannot be imaginary. So the imaginary is ruled out, and it should be either real. And if you could get the clarity that the roots are always positive or negative, then you can write that like a positive or negative. But if you see that the sum of the roots and the product of the roots, you don't have a control over the positiveness and negativeness of the product of the roots. So the AB plus BC plus CA can be, you can easily choose the real numbers A and B and C such that sometimes this product is positive, sometimes this product is negative. That means you can have one root positive, one negative, and one root both are positive or both are negative. Everything is possible. So you can't specify the roots are only positive or only negative. So this is also not possible, and then the real is the only thing that we can confirm. The sum of the roots is 2 times of a plus b plus c by 3. So instead of going for the product, the sum is better. Now see, you can take ABC values such that this is positive and this is negative also. So when the sum of the roots can be sometimes positive and sometimes negative, that means you can't say that both the roots are positive. Both the roots are positive, sum of the roots should be always positive. If both the roots are negative, the sum of the roots should be always negative. But here the sum of the roots is not always positive, not always negative. So that's why the roots are positive and roots are negative is not possible every time, right? The root of this equation, which has a greater modulus is what the question asks. So we can use the quadratic formula and get the root minus b. So minus of b is 4 2 minus I plus minus root of b square minus 4ac. B square is 4 times of 2 minus I the whole square minus 4 into 2 times of 1 plus I into c. C is this minus 5 minus 3I by 2a, and then 2 times of 1 plus I. So just need to do the simplification. Just a minus b whole square here, and then opening the bracket here, you'll arrive at this. I just simplified this. Minus 5 plus 3 is minus 2, and that minus 2 is common in these two. If you take the minus 2 out, that minus and minus plus 16, the plus 16 is taken common, then you remain with 2 plus 4i, and minus 4i plus 4i get cancelled, and then root 16 becomes a 4 taken common and cancelled. You remain with 2 minus I, the plus minus root 5, root of 3 plus 2, root 5 by 1 plus I. So when I took the 2 common, I will remain with only 1 here. So then I'll get this only root 4. So then it will be root 4 is 2. 2 plus 2, 4 minus I by 1 plus I is 1 root. And if I take the minus 2, so then this is minus I by 1 plus I is 1 root. They're asking with the lesser magnitude. So there is no need of simplifying this. So then we can calculate the magnitude of these. Oh, but still we need to simplify because the option is in form of a plus ib. So let us multiply with 1 minus I in the numerator. So then 4 minus I into 1 minus I by 1 plus I into 1 minus I is 1 square plus 1 square 2, and minus I into 1 minus I by 2. So this is definitely 4, 5. 5 minus I square is 1, 3. And then minus 4I and minus I minus 5I by 2 is 1. So 1 is there in the first option. But if you open the bracket here, so minus and minus plus I square is minus 1 minus I by 2. And the denominator is the same. And the numerator magnitude, if you see the 3 square plus 5 square, is definitely bigger than the 1 square plus 1 square. So this is the complex number with a bigger magnitude, and the first option is the answer. When it is given 2015. And the previous one is in 2016 itself. Yeah, this is given in 2016. And the previous one is also given in 2016. Yeah. If you think about elimination method for this problem, one is directly they are given as origin. So you have a freedom to choose a Z1 and Z2, satisfying that condition that they form an equilateral triangle. Let us take Z1 as 1, 0. Now Z2, you don't have a choice. I mean, of course, you'll have one or two choices actually. You can have Z2 here such that it is an equilateral triangle, or you'll have a Z2 here. But Z1, you can choose any number like other than 0, 0 in this XY plane. According to that, you need to choose Z2. So you should choose such that the distance, this distance is also 1, and this distance is also 1. And you know that this angle is pi by 360 degrees. Then automatically this length is 1. So polar form, if you depend on r cis theta, 1 cis pi by 3 is Z2. So let us write the Z2 in polar form for a while. Or else if you want to convert it into this point form, cos pi by 3 plus I sin pi by 3. Cos pi by 3 is 1 by 2 plus sin pi by 3 is root 3 by 2. So this is what Z2. Now, if you write the Z1 square, so it's easy to write in the polar form for simplification. Z1 square is 1 square, a Z2 square is cis pi by 3 the whole square, and Z1 Z2 is cis pi by 3 into 1 is the same, and this is 1 plus cis pi by 3 whole square is cis 2 pi by 3, cos 2 pi by 3 plus I sin 2 pi by 3. Okay, cos, okay, I'll just write it. This is 2 pi by 3 minus cis pi by 3. And now we'll write this in the a plus ib form. Cis 2 pi by 3 is cos 2 pi by 3 is minus 1 by 2. Plus I sin 2 pi by 3 is directly root 3 by 2 I. And the minus of that, minus 1 by 2 minus root 3 by 2 I. So these two get cancelled. And then 1 and minus 1, this becomes 0. So just because you're getting 0, you can't confirm this first option as a correct answer. You can only confirm the wrong answers with the elimination. Now, if you substitute directly the Z1, Z2 here, it's 1 minus 1 by 2 plus I root 3 by 2, which is definitely not 0. If second option is the answer, and the given expression should match with this for any particular values of Z1, Z2 satisfying this equilateral triangle condition. But for this particular set of values, this is not satisfying. This is the wrong option. And if you write the plus between them also, not much different. Okay, I think I missed a bracket here, but still it doesn't make a difference. It won't be 0. And here also it won't be 0. It's a wrong option. It won't be 0, wrong option. And 1 is the correct answer.